No, it's her brother's these dealers.
I could do that one then, like.
Don't do it. I go.
When you start, you just start yourself on F.
I know, she's trying to play. Not everyone down to the beat. I just choose.
No, someone in the same room one time, so.
Your turn. You should know. I thought you said the top.
They don't want you to tell me to stop.
No, it's just her. What's the first thing on the answer?
Yeah, it's just a birthmark.
Are you serious? What you think? I thought it was like rounded off. Whenever I She's the nicest. Guess what? Okay, so my brother, he went to a group chat. My brother got into my older you could never be my dad. She don't invite people. Wait, no, that'd be sad. And then when kids out, she
I'm gonna give you about 10 more minutes to get this completed.
You wanna hit me? Girl, just chill.
No, I'm kidding.
No, Dad.
That's my life.
Thank you, Dallas. Thanks.
You're so welcome.
Thanks.
Yeah. What's the website? Or like, what's the YouTube? What is it? Oh, they did?
Hey, smart girl. Hey, straight A student.
Just put it away.
Alright, here, girl.
Nodding.
That's not going. I need help. This is.
Hey, you about to get out of class.
You're made it. This is.
Go.
I was next after.
Let your sum at the top.
What's the I'm so confused.
Almost know why I'm at this.
So, you're gonna take that,
No, I'm saying like, okay, no,
move this over here,
no, I'm
move
going
this side, so then you have your pocket here, right? Yep, you with me? This up at the top, it's not on there, right? Like that. Move this up here to the top. Tuck that inside your pockets, so they're not all over the place. The solar system. Don't smile. Okay, you have about 5 more minutes. Up here on the board is an example of how you can glue it. So you can take a piece of paper, Logan. You can take a piece of paper and you can glue the sun onto that paper. And then you have your string hanging. Here you have the planets and you have the distances. Glue down the 3 sides, but keep the top side not glued so you can tuck your string inside of there, that pocket. Okay, so this is what you can put on there. Solar system scale model on your paper as well. So there is an
just a random piece of
example
paper.
your final. Huh?
Notebook or just random piece of paper?
You can use a piece of paper over here. Will work. If you have notebook paper, that's fine. Oops.
I did it!
I'm streaming. Ooh, there's another person here.
The paper's not big enough.
Alex, go pick that up, please, and you can have a lunch detention for throwing that across. the
Okay, I will. Some stupid kids, shut up! Swear to God.
He's so dramatic. That was so.
I thought it was good.
We don't need this much more.
He's so dramatic. I don't know, 6th grade was
What's up? What's
Alice, go sit down, please.
That's my uncle. Uncle can
2 more minutes. 5 more minutes. 5 more.
Then what are we gonna do?
Free time.
Bill Nye? Oh. I don't want to do notes.
Yeah, and she never responded, like. I gotta send
Oh.
So do we have to do that? Do we have to do
You can see swag.
Ándale, vamos. We go. Jesus, thank you. Okay.
Holy crap.
You know what I mean?
The average size is,
No kidding.
because girls like
Yay.
She has to there.
Be
Yeah. I'm done with for you guys.
Okay, let's start cleaning up our areas and getting back to your assigned seats, please. If you're done with your paper, paper, you can make sure your name is on it and turn it into a plate. Is it necessary for you to fling it?
No, she didn't do it.
Could've pulled my eye out.
I told her to see what she was doing.
It's big enough. What is this?
There's no what?
Poke my eye out.
Yeah, could poke his eye out.
Oh, God. Daddy, you move your chair. Oh, my God.
Yes. I'm streaming and there's 2 viewers. The school computers can't watch live streams, which means there's 2 random people in my chat right now.
Why are you just sitting there? It's so weird.
Because I can.
You just sit there and stare at it.
Someone subscribed from it, so.
Someone subscribed from what? 7 subscribers.
I actually now have 14 subscribers.
Oh my God.
He is famous.
Should I get him for your autographs right now?
Okay, if you're not finished, you still have a few minutes. I'm gonna play a video and you can watch and complete this while you are watching the video.
Outside, really.
Yes.
I mean, I all watch it. Ever since I was little, I always watch it.
It's like they get together one-on-one.
No.
The teacher means Monday after school.
Yes.
I know everything. I know exactly where your names are at. Or you're there.
I'm talking about my
I told you earlier. I know where.
No.
Where'd you guys get the?
I just saw myself.
Yeah, read.
I just type in the chat, bruh.
Wait, did I get him?
Not on the chat.
Darn it.
It's like up here, like around this area. This is their eyes right here. I just blinded them.
There, did I get him?
No, it's still a little too low.
Oh my God. There. Did I get it?
Right there.
Really?
Yeah.
Wow. That's a lot.
Amazon usually uses Buy. It's a browser extension that automatically compares Amazon's prices with other sellers to see if there's a better price out there. It includes tax and shipping in that price, so you know you're really getting a great deal. Plus, it's totally free. So do yourself and your wallet a favor and try Buy.
Try Wikibody, guys. Wikibody is a place I use it all the time on Amazon.
Searching for a beach vacation? Find it at Verbo. They search millions of homes to find your perfect beach house, where you all find your own rooms and some quality time to find out about each other. From beach houses to cabins to condos, find vacation homes that match you at Verbo.
We live in a pretty cool neighborhood, the Milky Way galaxy. We're out in the suburbs, sure, but it's still an interesting place, buzzing with activity. Stars, nebulae, stellar clusters of various sorts, the occasional supernova. It's a happy place. In the earliest part of the 20th century, astronomers were just starting to figure this all out. But there were a handful of objects that were puzzling. The objects sky here and there were pink fuzzies, displaying a variety of shapes. Some were round, some elongated, and some even seemed to have spiral arms. Even with big telescopes, they looked smoky, so they were simply called nebulae. Their existence was puzzling, though. What were they? How did they form? Were they big, small, near, far? Eventually, astronomers had uncovered the key to these objects, and in one fell swoop, our universe got a lot bigger. A lot In 1920, there were two competing ideas about the universe. One was that our Milky Way was it, and that everything we saw was in it. The other was that these spiral nebulae seen in the sky were also like our Milky Way, island universes in their own right. Two astronomers debated this controversy in that year. Harlow Shapley argued that the Milky Way was all there is, while Heber Curtis was of the opinion that we were one of many galaxies. It wasn't a debate as such, more of a presentation of ideas, and there was no clear winner. Both sides had fragmentary data, and we now know some shaky observational evidence that turned out not to be correct. For example, Shapley noted that one of the spiral nebulae had been seen to rotate, so it must be small. It turns out that was just wrong, dead wrong. On the other hand, Curtis noted that if galaxies were as big as Shapley claimed, hundreds of thousands of light years across, then other galaxies must be impossibly far away. But hello, galaxies really are that big. And they truly are mind-numbingly distant. The observation that finally unlocked this mystery was made just a few years later when Edwin Hubble and Milton Humason observed the great spiral nebula M31 in Andromeda, using what was at the time the largest telescope in the world. They found dozens of pulsating stars in it, literally stars that change their brightness in a regular periodic fashion. These are called Cepheid variables, and they were critically important because it was known that the time it took them to pulse was directly related to their luminosity, how much energy they emitted. That means if you can measure their period, you can determine how far away they are simply by measuring their apparent brightness. The distance they found to M31 was 900,000 light years, clearly outside even the largest estimates of the size of the Milky Way. They also resolved swarms of faint stars, cinching the fact that the Great Andromeda Nebula was actually the Andromeda Galaxy. At that moment, our understanding of the universe swelled in size, and we've never looked back. We've learned a lot about galaxies in the ensuing century or so. Each is a collection of at least hundreds of millions or even trillions of stars, and most contain some amount of gas and dust. They range in size from tens of thousands to hundreds of thousands of light years across, and they come in a variety of shapes. We use these overall shapes to classify them. Broadly speaking, there are four major types of galaxies: elliptical, spiral, peculiar, and irregular. The spiral galaxies we've seen, we live in one. These are characterized by broad, flat, rotating disks of stars, gas, and dust, a central bulge of older, redder stars, sometimes with a long cylindrical or rectangular bar of stars as well, and a huge extended halo of older stars. Some spirals have large central bulges, and some have much smaller ones. Most have bars of stars extending across the central part of the galaxy. Our Milky Way does. The spirals come in a variety of flavors as well. Grand design spirals have magnificent, well-organized spiral arms that extend from the very center out to the visible edge of the galaxy. Others have choppy or patchy arms. These are called flocculent spirals, resembling tufts of cotton. Some spirals have wide flung arms, while others are tightly wound. Spirals take on wildly different appearances depending on their angle to us. Some we see face on, and these may be the most magnificent objects in the entire sky. Huge and sprawling, their structure is obvious and easy to see. Star-forming nebulae are laid out like beads on a string, colored pink by the characteristic glow of warm hydrogen. Young, massive, luminous stars blaze blue, tracing the spiral's form. Filigrees of dust clouds align with the arms as well, and the central bulge or bar glows an eerie reddish yellow. The star formation there long since ceased. The bluer stars all exploded, leaving only the redder stars behind. When spirals are more tilted to our line of sight, some of this structure is hidden. And when they're edge on, we see them as the flat disks they truly are. Dust clouds are tightly restricted to the midplanes of spiral galaxies, and we sometimes see them bisecting the galaxy like a racing stripe right down the middle. The reason for this is the same reason our solar system is flat. Galaxies probably formed from huge clouds of gas billions of years ago. As a cloud collapses, small eddies in the gas would get amplified and would create an overall spin. This naturally leads to a flattening of the cloud. And by the time the stars in the galaxy were starting to turn on, the overall structure of a flat disk was in place. Elliptical galaxies are, well, elliptical. Kinda. Some are nearly spherical, gigantic cotton balls of billions of stars. Others are more elongated, shaped like cigars or American footballs. They tend to have no overall structure as spirals do. Ellipticals are puffy, and they range in size dramatically. Some are what are called dwarf ellipticals, just a few thousand light years across. to monsters that hugely outmuscle our own Milky Way. Besides their shape, ellipticals are characterized by a lack of gas and dust in them, and also are populated with older stars. Apparently, star formation in ellipticals came and went eons ago, and all the young massive stars have long since exploded, leaving less massive redder stars. This makes them similar to the stars in the central bulges of spiral galaxies. It's not exactly clear how ellipticals form. Current thinking is that they are the products of, and this is mind-blowing, galactic collisions. Yes, you heard me, entire galaxies collide. When galaxies collide, it's a train wreck on a cosmic scale. Galaxies are huge structures, and with hundreds of billions of stars in them, their gravity is pretty strong. If two galaxies get close enough together, they can draw each other in and collide. A galactic collision is a weird event. Even though the collision speeds can be hundreds of kilometers per second, the event plays out over hundreds of millions of years. Remember, we're talking about distances of tens of thousands of light years here. In the early stages of the collision, tidal effects can be strong. Stars on the side of the galaxy near the other one get pulled toward it more strongly than the stars farther away, so the galaxies can get stretched and long tendrils of stars and gas get drawn out. Generally, collisions aren't head-on, but more of a side swipe, so there's some sideways motion. When that happens, the tidal streamer can become curved, a long, graceful arc. Colliding galaxies in this stage form all sorts of bizarre and spectacular shapes. Sometimes the galaxies separate and then fall back together again. When that happens, the main bodies collide. But this isn't like two cars crashing together. Stars are very, very small compared to the space between them. So even though hundreds of billions of stars can be involved, the odds are good that no two stars will ever physically hit each other. Space is weird. Gas clouds, though, are huge, and they do collide. They slam into each other, collapse, and form stars at a furious rate. Colliding galaxies can glow pink and blue as stars are born and light up the hydrogen clouds around them. Sometimes the two galaxies will collide at high enough velocity that they pass right through each other. But even then, in most cases, they'll slow, stop, and then recollide. Eventually, they merge, their huge energies of motion absorbed by the orbiting stars, puffing them up into vast, sweeping orbits. The results, so we think, are elliptical galaxies. Not all collisions result in galaxies becoming ellipticals. If a big spiral collides with a much smaller galaxy, it can tear apart the interloper and literally absorb it into itself. So, galaxies are cannibals. We think most large galaxies grew to their current bulk by consuming smaller galaxies, including our own Milky Way. In fact, we have proof. We're currently in the process of eating several smaller galaxies right now. Tirzan 5 is a small knot of stars that may be the leftover core of a galaxy cannibalized by our own. And two huge looping streams of stars circling our galaxy are parts of the Sagittarius and Canis Majoris dwarf galaxies being torn apart by the Milky Way. This brings us to the third type of galaxies, peculiars. These are not shapeless really, but have a shape that's weird. Peculiar galaxies are essentially all due to collisions. Colliding galaxies clearly have structure, but can be all sorts of odd, distorted shapes. Sometimes a small galaxy will plunge right through the heart of a much larger galaxy. The gravity of the smaller galaxy draws in stars and then flings them away in the bigger one, like ripples in a pond. The result is a ring galaxy, sometimes with the culprit intruder seen nearby. The famous Cartwheel galaxy is a fine example of this. Another is Hoag's object, though, to be honest, it's not completely clear if this bizarre galaxy is a product of a collision or some other process. It's peculiar either way. Finally, we come to galaxies that truly are shapeless, called irregular galaxies. These tend to be small and chaotically shaped. Bigger ones may be victims of collisions, their shapes distorted so much that the structure was lost. Smaller ones may simply be too tiny to collect themselves together into a recognizable shape. Many galaxies have companion satellite galaxies. The Milky Way has a couple of dozen such satellites. The two biggest are the Large and Small Magellanic Clouds, visible from the southern hemisphere. Both are irregular in shape, though the Large Magellanic Cloud is barely coherent enough to qualify as a disrupted, though small, barred spiral. Both are riddled with gas and dust. The Large Cloud sports the biggest and most active star-forming gas cloud in any nearby galaxy, the Tarantula Nebula. It's producing so many stars that astronomers think it may be in the process of forming a globular cluster. There are other types of galaxies as well. Some, called active galaxies, pour out far more energy than normal ones. And galaxies aren't just scattered evenly across space. They tend to be found in clusters, some containing thousands of galaxies. We'll get to all that in the next episode. We now know that the universe is far, far larger than just our Milky Way galaxy. It's a recurring theme, isn't it? We thought the Earth was the center of creation, and then the sun, and then the galaxy. But every time we investigate these situations earnestly and engage in honest debate, we find that we're smaller and farther removed from the action than we thought, or than we thought we deserved. Astronomy is really, really good at putting us in our place, but it's also really good at showing us just how grand and awe-inspiring that place is. Today we learned that the Milky Way is a galaxy, one of many. Containing gas, dust, and billions of stars or more, galaxies come in four main shapes: elliptical, spiral, peculiar, and irregular. And galaxies can collide and grow in size by eating each other. Crash Course Astronomy is produced in association with PBS Digital Studios. Head over to their YouTube channel to catch even more awesome videos. This episode was written by me, Phil Blake. The script was edited by Clayton Agostino, and our consultant is Dr. Michelle Collin. It was directed by Nicholas Jenkins, edited by Nicole Sweeney.
All right, so we're going to be talking about galaxies and stars in the next section. So tomorrow we will take notes on that. If you are done with your paper, you need to get it turned in now. Otherwise, you will not get a full credit for it. So make sure your name is on it and get it turned in.
Ava, I need, hey, can I let me use your pencil so I can write my name on there?
Sure.
What's the, like, what's the size? We have to turn it in.
I think it's planets in the galaxy. I still have 2 years.
Cecilia, can you give that to me? Thank you. Here you go.
Thanks.
What was that?
You guys sit down in your seats, please, until
Can we turn
bell
these
rings.
in
You
again?
keep
Can we turn
it.
these in back in?
You're picking stuff up, that's fine. Put it away.
This paper could go already.
Yep.
Miss Rose, I will bet tomorrow.
Nope.
That's not good.
Look on the floor. I see colored pencils all over the floor. Go pick them up, please. Put them away. You see trash on the floor, grab it, pick it up, put it away.
What? What? Oh, this. I'm streaming. I've been for almost 38 minutes now.
There's not even on there.
What?
Is anyone on there?
There's 2.
Who?
I'm not sure. What? What?
Here, let me see. No, like, don't show me, but.
I was about to say.
Pretty cool.
That? I bet they're probably only on there because they're probably just sitting in class. It's probably the only reason.
They're not like
just really close friends with you.
No, I don't know any of these people.
But it's probably there's only 2 of them on there.
Hey, what's up, y'all?
Yes.